Alrighty, so here is um so basically here is our um kind of more notes for our unit 5. Oh, excuse me. So here are some more notes for unit 5. So right till this point I've only been able to get up until about unit um 5.4, I believe it is. These are the 5.5 notes, and these notes in this video, oh gosh darn it, I keep going forward. These notes This video might cover 5.5. We might be able to get to some 5.6 as well. The 5.5 is pretty short. It's literally just this one slide here, and it deals with imaginary numbers, which I know kind of sounds a little silly, but it actually is still something that we deal with in math. So um, basically, imaginary number here, it's essentially a number I that is the square root of a negative number. So in the past, we have, been told if you see, like, say, like for this one right here, if you see like the square root of 121, that, the answer would be no solution. But now that's technically no real solution, but the reason is because, there actually is a solution, but the answer is technically not what we call a real number, it's what we call an imaginary number. So this is kind of how we, would write our answers here. So whenever we deal with negative exponents or like negative numbers underneath the square root signs, the first thing we always want to do, kind of like what we've been doing before, we want to split up the square root there. But instead, one of the square root has to be -1, okay? Because we see what our property up here, I is equal to negative square root of -1. We're just going to substitute in I for that -1 right there in order to simplify it out. And remember, when we split it up, these two square roots have to multiply to get this top square root right here. So -1, what multiplies by -1 to get me 121? That is just 121. And then from there, just like we've been doing over the last few weeks, I do the square root of 121, which is 11. And then for the square root of -1, I'm not going to write, again, we can't take a real number and get the square root of -1. I'm going to substitute in I for -1. And it's kind of like this little curvy looking I right here. And I'm just going to write it like that, like 11 times the square, times I, or just 11I like this. All right. Same process right here. All right. We want to split apart our square root. We want to do the square root of a -1, and again, these two numbers have to multiply to get us -81, and that just is 81. The square root of 81 times -1 is -81. And I'm going to write parentheses, bring this negative down here. And then we go from there. We do the square root of 81, that gets us 9. Square root of -1, again, we don't put a number, we don't put a numeric value or literally like a numeral there. We would just put the letter I there. And then finally, this whole thing's multiplied by the negative, so I'm just going to multiply it by negative to get a -9I. All right. So now example number 3, I have -6 times the square root of -4. Kind of different because we got another number out front here, but we're going to still start with the square root, split it apart to get the square root of 4 times the square root of a -1. Again, we'll always want that -1 there, and again, we simplify from there. Also, I'm going to write down, make sure we bring the -6 down. Do -4, square root of 4 is just 2. I'm going to substitute in I for the square root of -1, so that's just going to be 2I. We still have the -6 out front, and just like if this was an x, all right. Just like, again, we basically treat the I like an x in this situation. If we have a number out front, -6 times the 2I, we just multiply the -6 and the -2. Just multiply those two numbers out front. You get yourself -12I for that example there, up there. Okay. Example number 4, we have I times the square root of 36. Now, if we look, we don't have a negative number underneath our square root sign. So we don't really need to split up the square root of 36. I mean, because we already can take the square root of a positive number. We already know that the square root of 36 is just equal to, I'm just going to write it over here, it's just equal to 6. Now, the only difference is we have this I out front. It's just going to be I times 6, which just turns into 6I, all right? Again, if we don't have the negative underneath, we don't have to split it up, or unless if we, need to break it down at all. Now we go over here, and I got negative 2i is equal to 49. Again, I look underneath my square root. There's not a negative underneath it. I have a negative out here, but it only if we only use imaginary numbers if the negative is underneath the square root signs up here. So again, I do my square root. Square root of 49, a positive 49 is just equal to 7. Multiply by negative 2i, and just like I did over here, I'm just going to multiply these two numbers right here, negative 2 times 7, to get me negative 14i. Gosh darn it. Sorry about that. And then right here, example number 6, just a real quick one again. So we got the negative out front there. Again, negative is outside of the square root, so we don't have to break it down, or we don't have to do any, we only have to break it down with the negative 1, but in case, we can't take the square root of 100 or the square root of the number, then we would break it down. But the square root of 100 is equal to 10. With that negative sign out front, just turns into negative 10. All right. Okay, now I want to do one last example. This one is technically not in your notes. Oh, get out of that. I'm going to go back in here. Sorry about that. I'm going to do one more example that's not specifically in your notes, but it's just kind of one that I wanted to show you guys. So we got I on the outside times negative square root of negative 25. Okay, all right, so let's work through it. So we have the square root of negative 25. We start by breaking down the square root here. We do have a negative that's underneath of our radicals, so from there we have to break it down as the square root of negative 1 times the square root of 25. And, if we go from there, we know that the square root of 25 is equal to 5. And in the square root of a negative I, that is just, we substitute an I for that, but we still have this I outside. Now, we haven't been multiplying our i's that much. Now, if we go back to now if you saw it on the last page there, and this isn't exactly in your note packet, but it's definitely something to know. If you have that I squared, all right, so first of all, we know that I squared is just equal to I times I, because again, you treat these like variables with an exponent, and we multiply these two i's, add our exponents, we get I to the second power. Okay, and that's the same thing we have here. This is also the same as 5 times I, and we have I times I there. So this is also equal to 5i squared, but also remember that if it's I squared, it's equal to I times I, and I'm going to substitute in I times I, which is negative 1 times negative 1, and remember what happened when we multiplied a square root of one number times itself again. Square root of a number times the square root of that exact same number. What we do is we just cancel out the square roots here, and it just turns into whatever number is underneath here. So square root of negative 1 times the square root of negative 1 just turns into negative 1. And again, if you see these for all these other examples, just reiterate, square root of 5 times square root of 5 is just equal to 5. Square root of 14 times the square root of 14 is equal to 14. We use that same logic to get that I squared is just equal to negative 1 right here. All right, because again, recap that. I squared is equal to I times I. I substitute in square root of negative 1 times the square root of negative 1. The square root of a number times the square root of that exact same number is just that number. Okay, it's just, it's negative 1. So from there, I know that I squared is equal to negative 1. So I'm going to write this up here. And again, when you're dealing with imaginary numbers, this is definitely an important property to know right here. So that basically tells me that anytime that I have an I squared attached to my number, I can automatically plug in a negative 1 there. Anytime that we can get rid of our imaginary numbers, we want to look to do that. All right, so I'm going to basically right here, I'm just going to plug in, this is 5 times I squared. I know that I squared is equal to negative 1, so I'm going to plug in a negative 1. That just gets me negative 5. All right. Okay, so I got a few more minutes left on my... I'm going to go ahead and open up another, kind of start another one here. I'll open up 5.6. So that's essentially the 5.5 notes right there. Actually, technically, even though this says 5.5 right here, it's a little bit different, but... No, not that. Excuse me. Sorry. So now we're going to deal with the 5.6 notes. All right, so that was 5.5 that we just did. These are now the 5.6 notes. It'll be part one here. We'll probably get through this one slide, and then we'll probably call it for the video. Now we're going on to adding and subtracting radicals. Now, wherever we're adding or subtracting radicals, we basically want to treat these like, combining like terms, all right? Now, as I said up here, simplifying radicals and then combine the ones that have the same number underneath the radical, that's essentially the key there. In order to add these together, they have to be the same exact number underneath the radicals. Just like, if you were to combine, 3x plus, 2y plus x, and I told you to combine like terms, we would only combine the x's. We wouldn't combine the y's. So it's basically the same thing here. We want to combine our like terms in order to, simplify down. So let's go ahead and do that. And if we look, none of these square roots have the same number underneath them. So from there, we need to break them down in order to, in order to see if we can add them any together. So first start off with, square root of 6. That doesn't simplify down at all, so I'm going to move on to square root of 24. And again, for this process, we're looking for perfect squares that break down our square roots here. And if we know 24, we can split that up as 4 times 6. I'm going to split it up as the square root of 4 times the square root of 6, with the perfect square being the 4 right there. And then the square root of 18 can be split up as the square root of 9 times the square root of 2, because again, 9 is a perfect square. We simplify these down, I get that the square root of 4 is equal to 2. Square root of 6, just like I said over here, can't be simplified down any further, so we just drop it down with it. I'm also going to drop down that square root of 6 as well. And then 9, the square root of 9 we know is equal to 3, and then the square root of 2, we can't do anything further with that. We can't break it down. We don't want to write it as a decimal, so I just break it down, bring it down here as the square root of 3 times the square root of 2. Now from here, you look to see where do you have your common radicals. And right here you have 6 square root of 6 times the square root of 6, square root of 6, and the 2 square root of 6. And just like if we were combining x's or if we were combining like terms, all we do is just add the numbers out in front. We don't change the numbers underneath the radicals. And this square root of 6 doesn't have a number out front. That means there's basically a number 1 out front. We add those two together, 1 plus 2 out front, we get 3 times the square root of 6. Again, we don't change the square root of 6 up at all. We can't combine the 3 times square root of 2 with the square root of 3 times square root of 6, so we basically just have to drop it down further right here. And that right there is going to be our simplified answer. All right, so let's work out this second example. So I'm just going to say right at the bat, these two right here, we can't break those down. Square root of 5 and square root of 2 can't be broken down any further. So I'm going to be looking at the negative square root of 45 to break that one down. Find a perfect square that goes into 45. I know that 9, which again is another perfect square, times 5 equals 45 with the negative out front there. Square root of 9 is equal to 3. Square root of 5 can't be broken down any further, so it just turns into 3 times the square root of 5. And then all this multiplied by the negative out front there, so it turns into a negative 3 square root of 5. And then, as I said, these ones up here don't break down any further, so it just turns into plus 2 square root of 5 plus 3 square root of 2. And then from there, we add our like terms. We have similar radicals right here with the square roots of 5. We just add the numbers out front, negative 3 plus 2, that just turns into a negative 1. Or you could even just write negative square root of 5. I like putting that negative 1 out there just to, show you guys. But you can also write this as negative square root of 5. And then plus 3 times the square root of 2. Again, that can't simplify down. We can't add that to this because there's not the same number underneath the radical. So we just do 3 and then plus 2 there. All right. And then the last example before we end the video, we have 3 times the square root of 2 plus 3 times the square root of 5 minus the square root of 2. And as we established over here, square root of 5 and the square root of 2, we can't break these down any further. So from there, we just, simplify what we can simplify. We have 3 times the square root of 2. We have the square root of 2's. These are the similar radicals right here. So we're just going to add the numbers up front. 3 minus 1 turns into 2 square root of 2. We can't add that. We can't add the 3 times the square root of 5 to it, so we just bring that down. It comes 3 times the square root of 5. All right. Thank you guys for watching. Next video will be up soon.